Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. So today we shall continue our video with this example and we're going to solve this quadratic equation by completing the square. So here is our quadratic equation for x squared plus x minus 3 is equal to 0. Now you can see clearly that this is your A is equal to 4. This is the coefficient of x, which is 1, B is 1, and this is C is equals to negative 3. So since A is not 1, A is not equal to 1, then what you need to do is you need to divide the whole thing with the coefficient, which is 4, and the right hand side also must be divided with 4. So next you can simplify it and it looks like this: x squared plus x over 4 minus 3 over 4 is equal to 0. Next, x squared plus x over 4 is equal to 3 over 4. Now here comes the part where you need to complete the square. So the idea of completing the square is that you need to replace this expression on the left hand side of the equation with something that looks like x plus a number, which is, you can call it p, and you square it. Okay, x plus a number and you square it. So how do we choose the number p over here? A simple trick is to consider, okay, for example, in this case we have x squared plus x over 4, and I hope you can see that the coefficient of x here is 1 over 4. Therefore, if I want to choose a number, it has to be x plus coefficient over 2 square it. So this is a simple trick that you can use it all the time in order to find the number p. Okay, now it becomes x plus coefficient is 1 over 4. Coefficient is 1 over 4 here, so 1 over 4 over 2 square it, so it becomes x plus 1 over 8 square. Now I hope you can see that it looks similar to what we are looking for. I mean, the form here is similar to what we are looking for here, so x plus a number square, but we cannot simply substitute x plus 1 over 8 square and say that this is equal to x squared plus x over 4, because they are not equal. Why are they not equal? Now if you look at this expression over here, they are not equal. X plus 1 over 8 square is not equal to x squared plus x over 4, so you cannot simply substitute the expression. Okay, now you can see that when you expand this, it becomes x squared plus 2 1 over 8x plus 1 over 8 square, and this is actually x squared plus 1 over 4x plus 1 over 64, which clearly is not equal to x squared plus x over 4 that you have over here. So how do we make it, or how do you manipulate this situation? So if I want to be able to have this form of x plus p square, I need to adjust and make sure that I minus with 1 over 64, so that the whole expression I have here is exactly equal to x squared plus x over 4. So now I have adjust the whole left hand side equation so that it really is similar to the above expression here, and this is equal to 3 over 4. Now what I'm going to do next is I have x plus 1 over 8 square is equal to 3 over 4 plus 1 over 64. Okay, next, if I want to get rid of the exponent, I need to introduce square root. So the whole thing must also be introduced the same thing on the right hand side. And therefore, I will have x plus 1 over 8 is equal to plus minus 3 over 4 plus 1 over 64. Sorry, this must be plus minus. I missed it. Okay, so I'm going to continue on this side. So next, I have x plus 1 over 8 is equal to plus minus. So 3 over 4 plus 1 over 64. That is actually 49 over 64. And that becomes plus minus 7 over 8. Okay. So now, what is x? So x is equal to negative 1 over 8 plus minus 7 over 8. Therefore, x is negative 1 over 8 minus 7 over 8, or x is negative 1 over 8 plus 7 over 8. And this one is negative 1. The answer is negative 1. And this one is 6 over 8, which is equal to 3 over 4. Okay, so these are the solutions to the second question. Okay, right. Now, here is the third method on how to solve a quadratic equation. We can use the quadratic formula. So this is the formula, okay? And before you can use the formula, you need to identify what is your B, your A, and your C, and it can be identified in this manner. So you must rearrange the equation in this manner and identify the value of A, B, and C, and then you plug into this quadratic equation. So the quantity inside the radical sign, so this is the quantity inside the radical sign, B square minus 4AC, is known as the discriminant of the quadratic equation. Now, if the value of b square minus 4ac greater than 0, there are two unequal real roots. If that is equal to 0, there is only one real solution, or repeated solution we call it, or double root. It's the same solution. And if it is less than 0, then the results will not be real. So it has two complex numbers where there are conjugates of each other. Okay. So in this example, I'm going to show you how to solve the quadratic equation by applying the quadratic formula. Okay, so for question A, so what I have is x squared minus 3x plus 9 is equal to 0. Clearly, your A is equal to 1, B is negative 3, and C is equal to 9. Now we're going to apply the quadratic formula. So x, this is the quadratic formula. Okay, and then you're going to plug in the values of A, B, and C into this formula. So you have negative 3 plus minus negative 3 square minus 4AC over 2 times 1. And then you can simplify. It becomes 3 plus minus 9. 9 times 4 is 36 over 2. 3 plus minus negative 27 over 2. So again, as you have seen in the previous slide, this is the value of the, this is the discriminant, and the value is less than 0. So if it is less than the 0, that means you have the solution, which is going to be complex number. Okay, two solutions which are going to be complex numbers and conjugate of each other. So we shall continue that with, okay, so let's continue. So we have 3 plus minus 9 times 3, 9 times 3, and you have over there is negative 1, okay, is over 2. So this is equal to 3 plus minus. So you can take out 9 over here from the square root. So it becomes 3. Square root 3. Now square root negative 1 is I. So you have learned this in chapter 4. Okay, complex numbers over 2. So the solution is x is equal to 3 plus 3 sub 3 over 2i. Or x is equal to 3 minus 3 sub 3i over 2. So these are two solutions, and you can see that they are conjugate of each other. Okay. Now question B, I will leave it to you guys to do it at home at your own pace. This is simple. What you need to do is, well, you can already identify this is A equals to 2, B must be negative 5, and C is equals to 2. And you just plug in into the formula, you should be able to get the answer. Okay. Now, you should know that when you have a quadratic equation, excuse me, it graphically means that it has a curved shape and it's called a parabola. And in particular, it looks like these three examples. The roots of a quadratic equation can be graphically represented as follows. If you have the discriminant greater than 0, you have two real roots at this point and this point. And of course, it is also possible to have the graph that looks like this. So you have two real roots, okay? If the discriminant, okay, is equal to 0, you have one real root, and if you have the discriminant less than 0, that means there is no roots. The graph is like hanging on this side, it doesn't touch the x-axis. Okay, so this is the graphic representation of the idea that you have seen in this part. Okay, right. Now these are the steps to solve a quadratic equation. So in general, you always make sure that the quadratic equation is in the standard form. This is the standard form, ax squared plus bx plus c equals to 0. If not, you can always rearrange the equation. Okay. And the second step is, if you can easily spot factors, you can use factoring method. It is always the easiest method in solving the equation. And otherwise, you can use the quadratic formula. I think quadratic formula is easier to work with compared to the method of completing the square. However, if the question asks you to work with a specific method, then you have no choice but to follow the order, or else marks will be deducted. Now, when problems are given in words, you can always follow the guidelines given on page 11. So this is the guideline seen for solving the linear equation. Okay, so that's all from me today. Thank you very much. See you in the next video.